question 43 is on polar and rectangular forms. So it's going back and forth. So you guys remember rectangular? Rectangular is just the normal x and y, okay? So we're going to go between polar coordinates, which are r and theta, to rectangular form, which is x and y. Okay, so it says you should be able to convert between these two forms. In order to do this, you will use several formulas. Okay, so our different formulas is that x is equal to r times cosine of theta, and y is equal to r times sine of theta. Remember those from vectors even? And then r is equal to the square root of x squared plus y squared. Or you might see r squared equals x squared plus y squared if you just squared both sides. And tangent of theta, any guesses what that's equal to? Y over x. It's very, very similar to what we did with vectors. Now, on your homework, I did notice some of you guys kept doing the little pointy parentheses. Don't do those. That's vectors, okay? Polar coordinates just have regular parentheses. All right, so it says convert to a polar equation. So we have x equals 4. So all we're going to do is we're going to try to change it so that it's like r equals something, okay? Just like if you would put it into a calculator, r equals something with theta. Okay, so what do we replace x with? What do you think? R cosine of theta equals 4. So if we solve for r, we get 4 over cosine of theta. How do you think that we write that? 4 secant of theta. That's it. Can you all do that? You're like, whoa, this is easy. 1 over cosine is secant. Remember first semester stuff. All right, so here we got x squared plus y squared. What did I say x squared plus y squared was equal to? R squared. So r squared equals 36.
Oh, I like these. R equals 6.
So r equals plus or minus 6, right? So this would actually be 2 equations.
The one I thought I had.
So this would be, you can write r1 equals 6, and you can have r2 equals negative 6 if you want. But yeah, it would technically be 2. Actually, you know what? I'm just going to say r equals 6. Alex, I think you are right. Okay, so why is r equal to just plain 6?
Oh my god.
Just like vectors, if it was like the distance, right, it's a positive. So we'll just say r equals 6.
Where's that bonus point?
I know. All right, so the next one, x squared minus 7y plus y squared equals 0. So we got to do a little moving around. So how about if I move it around to x squared plus y squared minus 7y equals 0?
Oh.
Yeah, x squared plus y squared, that's r squared. And then the minus 7y part, what's that? Minus 7 times r sine of theta, exactly. Equals 0. Now, when you get this, you can actually simplify it. We don't normally do this, but r is not going to be 0. Okay, if r is equal to 0, what does that look like on a polar coordinate if r is equal to 0? It's just a dot on the, we don't call it origin, what's it called? At the pole, right? Okay, is this a single point? No, that's some kind of curve. It's not a single point, right? It's not just the origin. So we don't write it that way. We don't leave. Do you see how there's a common factor of r that we can pull out? We always pull that out. So pull out the r to the front. So when we do that, we're going to have r and then r minus 7 sine of theta. And then it's like the r just goes away. You can divide it out because r is not equal to just 0. So our final answer ends up being r equals 7 sine of theta.
Not too complicated yet.
Yeah, still not bad. We got this. All right, y equals 5, easy. R
sine equals 5, so it will be r equals 5.
So we're dividing by sine, right? So what do you get when you do 1 over sine?
Cosecant.
Cosecant, good.
Oh,
Oh,
yeah,
Jordan.
I
All right, so still good? Now these ones are a little bit hard. X plus 1 squared plus y minus 2 squared, blah, blah, blah. Lots of stuff. Okay, you could go ahead and like FOIL it out as it is. Yeah?
Can't you just square root both of them? And then
You cannot just square root both of them. Just like if you had 9 plus 6 under a square root, or not, let me not do 6, let me do 36 or something. Let's say I have 9 plus 36. Is that equal to 3 plus 6?
no.
What's 9 plus 36? It's 45. What's the square root of 45? 3 root 5. Is that the same as 9?
Yes.
No. Do you guys understand? It's the opposite of this rule. Like that is not equal to 3 squared plus 6 squared, right? So taking the square root of both of those, that is illegal. We cannot do that. Illegal. Math police, yes, they definitely will come. At Sycamore, there was a teacher for a long time who charged $1. Did I tell you guys this? Every time her students did that, she would charge them $1 and she would take money from them.
If what?
If they did, I call it the freshman dream. Do you guys remember from Algebra 2? If they said that this was equal to x squared plus y squared, she would charge them $1. Those are not equal to each other. But the end of the year, she would always give the money back. Isn't that sweet of her? All right, so here we go. So you could FOIL this all out if you want to. I'm going to go ahead and do that now. It'll probably be a little bit easier. So I'm going to get x squared plus 2x plus 1 plus y squared minus 4y plus 4 equals 25. Do you guys see what I did there? So I took the x plus 1 times itself. I just didn't write that step. And I FOILed first, outer, inner, last. All right, so when I do that, I can at least see some of the stuff. I see that I have an x squared plus a y squared. So that's going to be replaced by r squared. And then I can combine my 1 and my 4. Let's subtract them over to the other side with the 25. So what do I get on the other side? 20. And I still have that 2x minus 4y. Don't you guys wish you could just move things over like this? Isn't it so easy? All right, so 2x is going to be 2 r cosine of theta. Oh, now I've messed it up. I can't do it. Oh, man.
Whoa.
See, this is what I get for saying, don't you wish you could just do this? Okay. And then negative 4 sine of, or negative 4y is going to be negative 4 sine, negative 4r sine theta. Okay, so we have that. And unfortunately, there's not much that you can do. I can't remember. I think on these ones, you just leave it. So let's just set it all equal to 0. I don't know. I gotta think about that one. Some of them, just like you know how some functions you can't solve for y, I think some of these you can't solve for r. All right. So this next one. So if I have 3x plus 5y equals 1, so we're going to do 3 r cosine of theta plus 5 r sine of theta equals 1. And again, not much you can do, right? You could kind of pull the r out and divide it over. Like, see how they have a common factor of r? And you get 3 cosine of theta plus 5 sine of theta. But it doesn't really look much nicer in this form. You get 1 over 3 cosine of theta plus 5 sine of theta. But you are at least able to solve for r in that one. Okay, so I'll have to think about that one. The letter E. Oh, I had 2 E's. The first E.
That's easy.
All right. So that was going from a polar equation to rectangular. So notice how we replaced the x's with r cosine of theta. We replaced the y's with r sine of theta. We replaced x squared plus y squared with r squared, I mean. Okay, so we're going to do the same thing but in reverse here. Okay, so if I have r, I'm going to replace it with the square root of x squared plus y squared. So when I do that, I'm going to square both sides so that I get x squared plus y squared is equal to 100. Okay, what this is a circle centered at 0, 0 with radius 10. Okay, we all know that from geometry, and we did it in Algebra 2. Okay, that's exactly what that was saying, too. If r is equal to 10, remember it's like you had 10 circles. So around the 10th circle, that's where you would have your curve. Does that make sense? They're exactly the same. They're just written in polar form versus rectangular form. All right, so now we have r equals 12 cosecant theta. So kind of use your knowledge from what we just did with the polar into rectangular, right? Any ideas on what we do first?
12 cosecant theta, 12 over sine of theta.
Yep, so we're thinking of this as 12 over sine of theta. Because we know if we multiply that sine of theta to the other side, our sine of theta is one of the things that we like. What is it? Yep, so y equals 12. Okay, so this one's set up for us. We have r plus r cosine of theta equals 4. So r is the square root of x squared plus y squared. R cosine of theta is what? And then equals 4, like that. Now this one you actually could solve for y. So, I don't know, maybe sometimes I'll let you leave it like that. But let's go ahead and try to solve for y. Okay, what do you think I would do to solve for y? Yeah, subtract the x over. We did this in Algebra 2 last year. Okay, we have to isolate the square root. So then we square both sides. So then we get x squared plus y squared equals 16 minus 8x plus x squared when we FOIL that out. So again, if you need to write that off to the side, do it. I didn't know how to do this until I was in college. I had the worst. I had to write down every step. I was one of those students. Do you guys do that too? Write down every step. All right. So as you subtract the x squared out, right, it goes away on both sides. So you end up getting y squared equals 16 minus 8x. Anybody know what shape that is?
Oh.
It's a parabola, but it's on its side, right? Do you know which side it opens to, right or left?
Left.
It opens to the left. Good guess, 50-50. It does open to the left. So you could leave it like that, or you could say y equals plus or minus the square root of 16 minus 8x. Oops, that kind of ran out of room. Let me write that smaller. All right, feeling okay about these? No? Uh-oh. All right, here's where it gets a little bit weird. Okay. So we know that we can replace, if we had r cosine of theta, we can replace it with x, right? But you guys see the problem in D? The problem with letter D is that we don't have like r cosine theta and r sine of theta, right? So what do you think we're going to do to both sides before we start? Multiply by r, that is exactly right. So we're going to multiply by r and multiply by r. Because we want r cosine of theta and r sine of theta. Okay, so we have r squared minus 3r cosine of theta equals 7r sine of theta. Now we can replace. So when we do that, we get x squared plus y squared minus 3 times x equals 7 times y. Okay, and this one you would not be able to solve for y. Well, you could by completing the square, I guess. Do you guys know what shape this one is?
It's a
Yeah.
Don't we know that x squared plus y squared equals 1?
X squared plus y squared is,
That's a vector.
we don't want to go backwards, right? It equals r squared. We don't want to go back to r. Okay, so I'll let you guys leave this one like this. We'll talk about completing the square in a couple sections. But. All right, theta. Theta is equal to pi over 4. Tricky. How do we get this into x and y?
Wait, look it up.
Would it just be y equals x?
It is y equals x, good. On these ones, when you have theta equals some kind of angle, the easiest thing to do is think about what the sketch looks like. Okay, so with our polar coordinates, we have theta is equal to pi over 4. That means every single radius that we have, our angle is pi over 4, even for radii. So we have that. And we know what that equation of the line is. It's just the equation of the line y equals x. That is the easiest way to do this problem. Now, could you make it more complicated? Sure. You could say tangent of theta equals tangent of pi over 4, right? Take the tangent of both sides. What is tangent of pi over 4?
1.
1. And tangent of theta, if you go back to our little cheat sheet here, tangent of theta is y over x. So you end up getting y equals x when you multiply over. So you could always do that as well. All right, F. These ones are super simple, but for some reason, everybody always forgets these, including Mr. Morrison. Every year, he's always like, oh, crap, what do I do on these? He's like, I want to make it like, you know, he's like, I just want to divide the sign over, and I know I can't. Okay, so what do we do for this one? What do you think? Yeah, multiply by r. So you're going to do r squared equals 2r sine of theta. And the thing that people always think is that they're going to square both sides because they know they want an r squared. You don't square both sides. Do you guys see how that doesn't help you? If you squared both sides, you get r squared equals 4 sine squared theta. That doesn't help us, right? We don't want to do that. Okay, so don't square both sides. Multiply by r. All right, so we end up getting x squared plus y squared equals 2 times y. That's it. That's another one where it's kind of difficult to solve for y, so we'll just leave it. I'm pretty lenient on those. All right, so here we go. So r equals 3 sine of theta plus 6 cosine of theta. All right, this is one where we multiply by r, right? So we're going to get r squared equals 3r sine of theta plus 6r cosine of theta. So we're going to get x squared plus y squared equals 3 times y plus 6 times x, like that. Okay, you can leave it like that. And h, again, multiply by r. So r squared equals 4r cosine of theta. So I get x squared plus y squared equals 4 times x. All right, this one would be pretty easy to solve for y. You can do that, or you can leave it. Okay, those are circles. Those ones. All right. Oh, that's it. Man, that's the easiest section ever. I used to put them all together, but I broke it apart into